Okay, how you doing? We're going to talk about how it is that I can find the tangent of a inverse trig function that involves a double angle theorem involved with it. So what I have written up here is I just want to simplify this trigonometric problem. I'm not asking you to solve for anything. I'm just literally asking you to do an order of operations problem here. So what I'm going to take a look at here is how am I going to simplify this? So the way that I do that is first I need to figure out that what am I doing. And in this case it says tangent of 2 times the inverse cosine, okay, which is the arc sine. The inverse cosine is not the same as the arc sine. So I'm taking the arc sine of 3/5. So what I'm going to do here is I'm going to take a look at this and go, okay, I'm going to relate it back to what if I had the tangent of 2 theta. And I'm going to take in place for that and say, okay, my theta is really just this inverse cofunction here. So the way that I'm going to take a look at this is I'm going to go, all right, so I have the cosine inverse, okay, of 3/5. Well, by this theory, this applies that if that is equal to theta, okay, then I know that cosine theta is equivalent to 3/5. And that is just a formula. And the reason that you come across that and you get that is from my earlier videos where I talked about inverse functions and the idea of what an inverse function really is and how does it come to this. So since I have this, what I'm now going to look at, well, tangent 2 theta is really just taking 2 times tangent theta, dividing it by 1 minus tangent theta squared. So all I need to do is to be able to figure out what is tangent theta. Well, guess what? Well, if I know that cosine theta is equal to 3/5, this all relates back to the idea of that this is the ratio of the x divided by r, which stands for the length along the x-axis compared to the radius of a circle. So if I have that information, I can very easily find tangent because tangent theta is the relationship of y over x. So I can now just go back and use Pythagorean theorem, find out what y is, and plug it into my little formulas here. So here we go. Pythagorean theorem states that r squared is equal to x squared plus y squared based off of a unit circle. So I continue on with this, and I have that x is 3 and r is 5. So I've now got that this is r squared, which is 5 squared, which is 25. X squared, which is 3, which is 9. So 3 squared is 9 plus y squared. And if you notice that this is actually a 3, 4, 5 triangle, so you'll find out that when I subtract 9, I'm going to get y squared equals 16, and I take the square root of that. So y squared equals 16, I take the square root, and I end up getting y is equivalent to 4. Now that I have y as 4, tangent theta we now know is y over x, so this is 4 over 3. Okay, so that now gives me tangent theta, and what I now begin to do with that, okay, so this information here that I've used, what they've given me to apply it to this, I come over here and I plug it in. So the final answer to this is 2 times, so I'm just going to plug into this formula, 2 times tangent theta, so 2 times 4/3. And I'm going to divide that by 1 minus 4/3, the quantity squared, and then from here I'm just going to simplify. So this is 8/3 divided by, well, 1 minus, well, 4/3 squared is 16 over 9. So 1 minus 16 over 9. So now I have to actually do this because I'm now going to have to simplify a complex fraction because I have fractions within fractions that I need to turn it into all just one fraction. So if I take a look at this bottom part here, 1 in ninths is really 9 over 9. So I'm going to go ahead and simplify that there. So now I have 9 over 9. So what this then becomes is that I really have 8/3 divided by, so 9 minus 16 is negative 7 over 9. So the last thing I have to do is multiply the top and bottom by the reciprocal of the denominator because this is just basically at this point a complex fraction because I'm really taking one fraction divided by a fraction. And how is it that you divide fractions? You keep, change, flip, some people call it, but it's really just multiplying by the reciprocal. So when I do that, I take negative 9 over 7 times it by negative 9 over 7. So now what I have here is I've got 8/3, so the bottom is 1. 8/3 times negative 9 over 7, so if I do some front-end reduction here, 9 divided by 3 is 1, there's a 3, so what I'm left with here is 24 negative 24 over 7. So my final answer to this is equal to negative 24 over 7. And I don't write an equal sign or anything like that. I can just box my answer because this is just as if I were doing a order of operations problem.